Hi guys, this problem looked interesting. Let's look at it. So this is from AMC 12B 2023, problem 5. You're playing a game. A 2x1 rectangle covers two adjacent squares, oriented either horizontally or vertically of a 3x3 grid of squares. You are not told which two squares are covered. Your goal is to find at least one square that is covered by the rectangle. A turn consists of you guessing a square, after which you are told that the square is covered by a hidden rectangle. You are told whether that square is covered by the hidden rectangle. What is the minimum number of turns you need to ensure that at least one of your guessed squares is covered by the rectangle? Okay, this one's interesting. So, okay. What are we asked? We're asked to find one of our guessed squares is covered by the rectangle. So, if we were to draw this out, we have a grid, like, oh guys, I'll be right back. Okay, I'm back. So if we look at these, you can at most check 9 squares. And when you check all 9 squares, you're gonna check the two, you're gonna check both the covered hidden squares. So 8 makes sense because you would check all of them. And then let's say this one has it, you'll check that one. So you'll, like, since you're checking 8 and 2 are covered, you'll always check at least one. So that would make sense. But I think that if we check, since I'll use blue. So the um since the like thing always goes here, it will always go, I believe, in one of these 4. Right? It will always go here. Because it covers 2, it always goes on one of these 4. So if we just check these 4, that will always tell us. We'll always check at least one. So that means that we could cross out these. Can it be 3 though? Well, like, let's say we did these 3. Because, no, then it could be there. Maybe, like, if it's these 3, then it could be there. This is problem 5, and this seems like this seems like it will be the solution, because it's not that. This is like a pretty trivial solution. Not trivial, I don't know, this is a pretty easy solution. And it wouldn't make it that hard for problem 5. And I'm never covering 2 of my check squares, which indicates to me that it's probably a good solution, because I'm not wasting. Yeah, okay. Well, yeah, okay, I'm happy with this. I could do an alternate solution would be like this, just like this x, but that gives us 5, so we're not gonna count that. Okay, so I'm checking the answer right now. This is problem 5, I think. What's this? This is problem 5, yeah. Yeah, it's 4. Yeah, they solved it. 3 by 3 rectangle has 12 possible 2 by 1 rectangles. Okay. You choose the middle square for one of your turns. The middle square is covered by 4 rectangles, and each of the remaining 8 squares is covered by a maximum of 2 uncounted rectangles. So if you choose the middle, the maximum number of turns is 5, which we actually saw. Now suppose that you don't choose the middle square. Squares on the middle of a rectangle will cover it by at most 3 rectangles. 2. Okay, this is some math thing. Oh, okay, yeah, that's a good way to do it. They just said to minimize our number, we just look at all squares that are not, like, we only choose squares that are not adjacent to other squares. And the two ways are this x, like this, or this diamond. And one is 5 and one is 4, so just choose the one that's least. We chose the better one. So, yeah, we got this right. So, thank you guys for watching. I'll see you guys tomorrow. Goodbye.